In the early stages of growing colony is approximated by this formula here, where n is the number of bacteria. Is that okay? Now, and I use capital T, right? Now, find the number of bacteria in the colony after 4.5 hours, correct to the nearest whole number. Okay, but give me a sec. Oh, that's handy. It's all there for you, isn't it? So if I put this into my calculator outright, this is a nice question actually. 450, what's it? E? Sorry, 450 shift E 0.065, replace T with X. So just give me a sec. Start at 0. I'm going to end at 10. I'm going to do a step at 0.5. And see the way every half an hour or what's happening to your colony? It's growing in size. Would you agree with that? All the way up to 4.5 hours, which is 602.9 to nearest whole number 603, right? So it's 450 e to the power of 0.065. You want to show a bit of inputting for marks. And what do we agree on? 603? Easy money, that first question, isn't it? Okay. Now, let's go down to A part 2. Find in hours the time it takes for the colony to grow to 790 bacteria. Now, if I search through my table function, let's keep going. When does it reach 790? Oh, it's slowing down here. In between 8.5 and? Yeah, well, you can't tell for sure, but in between 8.5 and? Isn't it great, though, that we know what answer we're expecting? We already know what we're looking for. It's just a matter of using the maths to find it. So here we go. What do we replace n with? 790. Yes. Yeah. Trial and error won't get you full marks. No, the backup plan. Okay. Now, what do I do now? Divide by 450. What's 790 divided by 450? I'm sure we'll use the calculator, won't we? Exact. Keep it as a fraction then, okay? Because fractions are more accurate. Now, what's the general rule when we have a letter that's in the power position? Log either side, any log you want. What log should we use? Y. Yeah. Good job. I'm hopeful. Hopeful. Bring the power to the front. 0.0 ln e. And then over here. Yeah, keep it the same, don't you? What is ln e? 1. So it doesn't matter. And how do we get t on its own? And if we don't get an answer between 8.5 and 9, isn't that great though that you've called your shot? You know where it is, and the maths just backs us up then. So you have complete control over that. You know if you're correct or not. I got a syntax error, which means I just forgot to bracket it off. 8.66. How many decimals does it want? So 8.7. 8.7 could be good. All good. Move on. Okay. Using the function, find the average number of bacteria. Keyword. Keyword. And what does that usually mean in a paper 1 question? Means 1 over. You can keep it open for time being if you want. Like. Yeah. No, it's the 12 over the 3. The 12 is always going to be the top one. No, it shouldn't work. That'd be the opposite way around. So it should be 12. The top one's 12 and the bottom one's 3. So what we've cleared up at home is that you can have any variation of this formula that you want. The main thing is the big number goes on top and the bottom number goes on the bottom. Okay. Now, what is it? It's going to be 1 over 12 take away 3, which is 1 over 9, and then after that, 12 and 3. And what's it, 450 e to the 0.0 t to t, yeah? Now, what happens when we integrate an exponential? It stays exactly there, all right? And the 450 stays exactly the same. What's the only thing we change? 1 second. It's the only thing we change. You gotta differentiate the power. What happens when you differentiate the power? I'm just gonna put it at the front. Is that okay? Yeah. You do. Now, lads, see that ninth? That ninth could go back in and actually turn that into a. What could it turn it into? It could turn it into a 50, couldn't it? I'm allowed to do that if I want. I think I actually might use that opportunity to do this. 1/9 of 450 is 50, isn't it? Yeah, that's perfect. I'm all for that. Multiply it by 50, isn't it? 13 over 4, otherwise known as 3.25. And 3.25 e to the 0.065 t. And it has to go from 12 to 3. 12 to 3, cool, you guys? And we lob it in, and what do we get? So we're going to get 325 e to the 0.065 times 12. Now we're going to take away 3.25 e to the 0.065 times 3. What you guess your answer? 743? Okay. Is 743 a reasonable answer? Well, it is actually, because if you go back to your table function, we were averaging in the 6 and 700s, aren't we? From 3 to 12. So it's a reasonable answer. For those of you that didn't catch that, when we did the table function at the start of the question, we started off at like 600, 650, 690, 700, and then we eventually went up to 800. So the average being 743 is actually quite reasonable. Question. Rate. What does the word rate usually mean? Usually means the first derivative's on. Okay? So we're going to differentiate this. What's the rule when you're differentiating what happens when you differentiate e to the x? You get e to the x, yeah? What happens when you differentiate e to the 3x? You get e to the 3x, but then you differentiate the power, and you get another 3, don't you? So that's rejogging your memory. So here's what we're hoping. The 450 does just go straight in. The power goes straight in. What's the only thing we have to differentiate? The power, and what do we get there? Just this, isn't it? 0.065. You're just differentiating the power, aren't you? Multiply that by the 450. Is it? Good job. And what do we replace t with? Okay. Into the calculator with it. Oh. Sorry. 63.8. Okay, I'll just verify that with the lads there. Is any of this like very familiar with us at this stage, or? Yeah, 63.8. We all good? Okay. After k hours, the rate of increase is greater than 90 per hour. Find the least value of k. That means first derivative is what? First derivative is bigger than 90. Interpretation, thanks. Sorry guys, the interpretation is that your bacteria is currently rising at a rate of 63.8 bacteria per hour. So your interpretation is 63.8 bacteria per hour. It's on the increase, isn't it? If that was negative, the bacteria would be dying off and your population would be going down. Okay, next one. Do you want to get lights there, lads? Sure, call. Now, first derivative is bigger than 90, is that correct? And what was the first derivative again? This here, isn't it? Except no 12, just a t. So the first derivative was 29.25 e to the 0.0 t greater than 90. All right, I have an idea for you for a rough guideline. Look at this. I'm going to go into my table function. You ready? And I can get myself a rough guideline for this. 29.25 shift e 0.065x, yeah? And I'm going to start at 0 and at 20, step of 1. Look at this. Initially, my bacteria is grown by 29 bacteria per hour. And then after 4 hours, it's grown at 38 bacteria per hour. I'm going to keep going until I see 90. There it is. But in between the 17th and 18th hour, the bacteria is grown over 90 bacteria per hour. Just because this is the first derivative, it's not the original function. I'm actually graphing the first derivative. Now here's what we're going to do to find that out. What we're going to do is we're going to put it equal to 90, divide by 29.25, and then ln it. So 90 divided by 29.25. Yeah, to be fair, this question does have a bit of everything in it. 40 over 13. Sorry, I should have done that there. Okay. What now? ln both sides. Bring the power down and divide. And then divide by 0.065. And you guys tell me what you get. 70.29? 17.29. So 17 point. What you get? 17.29. So it has to be 18 hours, is it? Yeah, it has to be K element then. And 17 doesn't cut it. The 17 is too small. So it has to be 18 hours. And we already knew that, didn't we? Between 17 and 18. Right, lastly, a different colony of bacteria has this much growth. Now, I think if I remember this question correctly, is we want to find out when the population of both colonies are the same. So we have a P equals N, isn't it? We have 220 e to the power of 0.17. T is the same as, what was our old formula? 450 e to the 0.065 t. All right. You can't ln both sides. Can anybody tell me why I'm not allowed ln both sides at this point in time? See the 220? You can't bring the power to the front because that power, that 220 has nothing to do with the power. So what I'd be inclined to do is I want to get rid of the 220 and the 450 onto one side, and I want the e's over the other side. So here's what I'm thinking we're going to do. Ready for this? I'm going to keep e to the power of 0.17t on top, and underneath it I'm going to bring the e to the power of 0.065t. And then on the other side I'm going to have 450 divided by 220. Because what's called the power rule? What's x7 divided by x5, anybody? What's x7 over x5? x2, isn't it? You take them away. So what are we going to do with the two of these then? Take the two of them away from each other, and what do we get? E to the power of, is it 105t? And equals 45 over 22. Just divided by 10, didn't I? Then what can I do now? ln. Pretty much after this question, you never need to do an ln question again. You've just used it so often, haven't you? What goes to the front? 0.105 T. And what else? ln 45 over. And then what happens then? And what time do you reckon? 6.82. Cool with that?